Okay, let's start.
Sorry, before we go on, I think maybe we're supposed to change our calculations to that when we're doing the example. No, the one yesterday is sitting. But okay, we will discuss it later. It's fine. We don't mind.
We change our calculator.
No, no,
It says that you don't.
sure. Because
Yeah.
we had a pi there,
Yeah.
so maybe
Which question you? Which one?
okay. You do the one and two, just not confuse. Yeah.
Okay. Remember I told you for this one here you don't need to. Thank you. They don't tell me that you're not going to give me, and then I felt so hurt.
That was
That was because we
Bilal.
yeah.
That was Bilal.
Bilal said you're not going to
Yeah.
give me. So hurt.
But luckily, Nikki was giving up.
No, you know what? I got it because I understand my homework.
Oh, luckily it's not. Okay, so we're looking at your homework, which was activity 2.2. Okay, so
Just one last thing.
Yeah.
For the exam, when we're writing these tests and stuff, can we use a pencil to write down? Can we write with pencil?
yeah, as your final answers next time.
No, like the whole thing is like, you know how we're writing a
Yeah.
pencil? Again,
No, you can't submit with pencil to me. You can do your rough working and all with pencil, but your answer must be inked. Because in the exam, if you do that, they anything in pencil they ignore it. So you can write the whole thing out and have the final answer to it, but they'll just check it.
okay, so it's not useful.
So it must be inked, right?
Okay.
Because
So
what some people do.
planes and all that.
No, that they will, can obviously be in diagrams and stuff. That can be in pencil. But when you're writing out your answers, the numbers and stuff, because what some people like to do, because they make mistakes, they'll write out the whole thing in pencil, erase, carry on. So what happens is, towards the end, you run out of time to actually ink your work. So you spend the whole paper writing in pencil, and then when you come to the end, when you try to ink it, you don't have enough time. So then you end up losing out for that.
So just write with pencil.
Yeah, write with pen. If you make a mistake, just scratch the entire thing and keep on going. We'll give you an extra writing material and stuff. Okay. Yeah. So activity 2.2. I'll give you a question 1 and 2 to do. Okay. So question 1, they tell you that a flywheel rotates at 18 revolutions per second. What did it give you?
N.
They gave you n, right, which is your rotational frequency. 18 revolutions per second. Its diameter is 0.4 meters. Calculates angular velocity. Okay? So, angular velocity is equal to what?
2 pi N.
2 pi n. We're given our n, right? So this will be 2 pi 18, which will be equal to 0.97 radians per second. Okay. Next one. Calculate the angular displacement during circumferential velocity. So how would you work that out? What are they asking you for?
So is that linear velocity?
Yes. Okay, circumferential velocity is the same as linear velocity. So the formula for that will be V is equal to W times radius. Okay, do we know this?
Yes.
Do we know this?
Yes.
What is this? It's going to be half of this. So our radius is equal to 0.2 meters. Okay, so this will be equal to 113,097 times 0.2, which is equal to
22.619 meters per second.
meters per second. Okay, good. Last one. No, second last one. The angular displacement during 3 seconds. So how would you do that?
WT.
Angular displacement is equal to WT. We know angular velocity is 113.097, and then they're asking for 3 seconds. So this will come to 291 radians. Okay. Last one, they ask you the distance covered by a point on the circumference of the flywheel during 3 seconds. How would you work that out? S is equal to R, right? So we know this value is 339,291. The radius is 0.2. This will be equal to
67.858.
huh?
67.858.
8 meters. Okay, everybody got the right?
Yes.
Fine, so bad. Okay,
I got confused on that B one. I didn't know what the circumferential velocity is the same as a
It's
linear
linear.
velocity. Yeah.
okay.
So
So even
as
if they
a
ask
result,
for
I was
circumferential distance or circumferential acceleration, it's all the same as linear. Okay?
Okay.
Next one I gave you was question 2. So they tell you an axle rotates at 200 revolutions per minute. So this axle rotates, they gave you the value of n, which is 200 revolutions per minute. Calculate the rotational frequency in revolutions per second. So all they want you to do is convert this to revs per second. So how would we do this? We would say n is equal to 200 revolutions per minute. So if you use your stick method, 1 minute is equal to 60 seconds. So then that will cancel. Our units now is in revolutions per second. So this would be 200 over 60, which is
3.33.
revolutions per second. Then they asked you to set.
What time?
Then they ask you to angular velocity. How will you work at angular velocity? 2 pi n, which is equal to 2 pi 3,333, which is 942 radians per second. Last one, they ask you to calculate the angular displacement during 5 seconds. So how would you do that?
WT.
WT. So you would say angular displacement is equal to angular velocity times time, which is equal to 20.942, and what was the time? 5. So this would come to 100.
104.709.
709 radians. Okay. Does anybody have any issues with that? Sure. Good. Okay. Make it another mark, right?
Testimony feel confidence solar power.
Okay, can you take the verb?
Check how fast it's answering.
Yeah.
Check how fast it's answering.
People are saying
Who?
we all got it right.
Why?
So no need to yeah. For the case,
Take that down.
Yeah. Take a picture.
Missed it. You already
Okay.
missed it.
So now we're looking at page 38. We're looking at torque, work done, and power. So the moment of a force about an axis is the energy transferred to the axis by the force due to its magnitude and position. It is calculated as the product of the force and the perpendicular distance between the working line of the force and the turning point. 38. Okay, so that's, you'll see more what they're referring to on the next part, right? So we're talking about torque. So torque is the tendency of a force to rotate an object about an axis, pivot, or fulcrum. Okay, so you can see how they got the spanner with the bolt inside, or the nut.
Yeah.
Right? So when you turn the nut, you turn it basically on the center point of the nut. Right? The force is being applied onto the center point. Okay? So they tell you that when a shaft or nut is subjected to torque, the material of the shaft resists the torque being applied. Okay? Obviously, right? So that steel, if you're turning steel onto steel, the material itself will resist it, right? Your force that you're applying it on it. Otherwise, it will just fall through normally. Or maybe the way the thing is grooved will also resist it. Okay?
Then about the friction or the actual?
Friction is the resistance.
Yeah, but also the tension would also be the resistance.
Yeah, all those factors, because that comes from the material that you're working with. Okay? So torque is equal to the force multiplied by the perpendicular distance between the turning point and the working line of the force. Yeah. So the distance that they're referring to, can you see the diagram above that, from the center point to where they have the applied force? The value of R. Can you see the straight line? Okay. And then you can see the force being applied. That's your distance between the turning point and the working line of the force.
Yeah, I thought R was friction. Oh, no.
R is the distance between the turning point. So turning point is that center point of the nut.
Yeah.
And then your working line of the force is the F coming
The
down.
way it's being applied.
Yeah.
Yeah.
The way the force is being applied.
Okay. So so that's your value of R. And then the force being applied is your F coming down. Okay. So that thing needs to be perpendicular in order for you to do your calculation. And you're going to see in the example when we do it, okay? So the formula that you end up with is torque, this is a symbol for torque, is equal to force times the distance. Okay? So your force is measured in newtons. Your torque is measured in newtons per, what's this is? Torque.
Meters. That's meters.
Okay, so that's the formula you have. Okay? Work done by the torque. So for one revolution, work done is equal to force times your distance. I'll give you time to take it all down. Let's just focus on the formulas there. So for one revolution, work done is equal to force times distance. And they broke up distance into pi times the diameter. They further broke it up into pi times 2 of your radius. Once they did that, they grouped the force times the radius, which would be your distance, and then they ended up with the formula for work done being, so work done is W 2 pi times the torque. Okay? That's the formula for work. Okay, 2 pi torque. Power is equal to work done over time, or it's equal to 2 pi N torque. N will be your revolutions, your rotational frequency.
What's the units of your work?
Or units of work, this is joules. Work is in joules. Okay? Power is equal to work done, which is W all over T. Which is T. Power's units is watts.
What, sir?
Okay, 1 joule per second is equal to 1 watt. Okay, so the units here you would have had would be in joules per second, and 1 joule per second is equal to 1 watt. Okay, that's how you get those units. Okay, so that's that.
Formula like what the 2 pi n c what is
That's what W scattered it out.
not the n?
Or the N is rotational frequency.
Okay.
Oh, I never had
I don't know what's I see it here.
2 pi N torque. So this here is
No.
okay. Then we tell you on the next page, right? On top of page 39, work done if the force describes an arc. Okay, so if the force being applied, remember with the other one we looked at it as, that's your center point. This would be your R from here to here, and the force applied was directly perpendicular. Okay?
Right.
If the force being applied describes an arc, so if your force is basically at an angle, so if the force was being applied like that, this would be your R, but your force is being applied like that. Okay? Then the formula for your work done will be equal to F. So they say F times the arc, they broke it up further, and then you end up with work done being torque times the angular displacement. So remember that yesterday we looked at angular displacement? That's going to be that. So, how can I... Okay, I can take out these four formulas.
That's it. No other equations. No.
No, yeah, it's just. Remember, this is in addition to angular motion with the other supplements.
So you have those questions and you have this followed.
Yeah, they'll probably ask you to calculate the work done, the power. Yeah.
Well, they might work backwards, tell you work out rotational frequency.
From there, maybe,
From
giving the
giving
force and
the-
stuff.
The work.
And then they tell you work on angular velocity, like that, something like that. Amazing, he's always crooked, eh? How you do so well, sir? Just fall.
You didn't see all our heads like this.
Yeah, I don't know why when I let my man just goes.
So we can have another, we're going to be checking out with all three of y'all who's got the least handwriting.
Yeah.
Yeah. That's what we're going to do. And then we're going to give you our lessons on how to write.
Well,
Yeah.
shut We start drawing lines and all.
So the power is watts, which is joules per second.
Yeah, so 1 joules per second is equal to 1 watt. I think that's okay. This
Pull that stomach in. The stomach is blocked.
His jersey is big, man.
Yeah, I know. Whatever.
You got it again? Can I take it out?
Goodie bag. It's like a goodie bag.
Hello?
I don't know, it's much of food you think.
Then okay.
You get marks for just writing the formula down.
It's dependent on the question. If they give you the formula in the data sheet, then you're not going to give you marks for that. But if you remember it yourself, but they give you marks for substituting into the formula, because then you actually did something. Okay, so the work done is equal, no, chalk is equal to work done is equal to
2 pi top.
chalk, or work done is equal to INT. Okay, so let's look at an example, right? Example 2.5. What? Which one looks different?
How?
Why?
He told us work is equal to 2 pi in terms talk.
No.
Work is equal
Yeah.
to
Yeah,
2
that's it.
pi
It is there. Oh no, no, put the time underneath. No, you missed out the time.
Where?
The power one.
This power here, power is equal to work done over
Yes,
time,
the
or
time.
it's equal to 2 pi NT.
Yeah, it's not under.
Over T.
What you
It'll
give
be
us?
over
Yeah,
T.
the first one.
No, it's not over T. It's
Yes,
either this or it's that.
Okay, but because putting the N in will make it different from the one.
For the yeah.
Okay.
So this is what you gave us? Maybe I'm missing something here.
Oh, you're putting
You
the
said
end
work
there.
is equal to
The
2
N, yeah,
pi.
N
That I
is-
agree with that. You also said work is equal to 2 pi.
No,
Rotation.
power is equal to 2 pi.
That's how you wrote it on the board. It's basically telling us work is equal to.
No, it's not.
No.
There's a
No,
N in
there's
it.
the N,
There's
no,
a
the
N
N, it's
in
not the
power.
N, there's the N in power.
There's an N in power that makes it different.
Yeah, you see how she wrote it. You skipped half.
There's the N of
Take
it.
first the calculator, now the board. I don't know. I give up. Okay.
Doesn't have an N in the power of the N.
You're fine.
Yeah, sorry. my-
Okay, example 2.5. So they tell you that a force of 400 newtons is applied to the end of a spanner making an angle of 60 degrees with the spanner. Okay, so let me draw the spanner point first, right? So this would be the center point with which the spanner is acting on. Okay, this would be the length of the spanner, and this force is making 60 degrees with the spanner. So if you draw the force, that 60 degrees would be here. Okay, the force applied is equal to 400 newtons. Okay, the length of the spanner from the center of the nut to the point of application of the spanner is 0.25 meters. So from the center of the nut to the point of application is 0.25 meters. Okay, so that's where your force is acting. Calculate the torque. Okay, so we know that torque is equal to F times R. It's your force times your perpendicular distance between where it acts on this point and where the force is applied. Is this perpendicular to the distance? No. Right? So how would we do that? Doesn't this line here break up into two portions? Your vertical component and your horizontal component. It was gonna come back at some point, right? Okay, so this breaks up into a vertical and a horizontal component. What component is this?
Your Y. So it'll be
Your vertical component, okay? So your vertical component, is it now perpendicular to this?
Yes.
Yes. But how would you get this vertical component?
sine.
You use sine.
Sine.
Okay, firstly, let's just say, where is your angle?
Yes. Next to 60.
On the Y. On the x-axis.
Your angle will be
On top.
top here.
No, you could use.
You can use either 60 or 30 degrees. Whichever.
60.
No, you could use 60.
So you're going to use an angle. If you're going to use sine, you're going to need to use the angle on the y-axis, so that's 60 degrees. And then, so instead of drawing it down there, if you put a dotted line here, then you can use sine of 60 times the
If you use the
100,
30,
and then you get your answer.
Or just this is 30 degrees, right? This is 30 degrees. Okay? If it's 30 degrees. If your angle is here, what does it make this part? Adjacent. What you use adjacent here? Cos. So this will now be equal to F cos of your angle. Agreed? Yes? Yes. So now your force, your perpendicular force will be equal to F cos of the angle. Right?
But coming back to what Trevor said, you can also use
Now you see, you swap it
F
around.
sine.
No, it's not swapping. This is, do it like this. Don't mix it up, right? Keep this, if you want to do it yourself like that, do it like that, but
No,
you're
we
gonna
need to know it's both can work.
yeah, because remember if you draw the line here and if you say sine 60,
Yeah.
it's still opposite is gonna give you the same
Same
figure,
thing, correct.
right?
Yeah.
But when we're drawing it for the sake of the diagram, the way the force is being applied,
Alright.
keeping it like that. Okay? So this will now be equal to this force here. Remember it's perpendicular force, so this will be equal to F cos of your angle multiplied by R. So this is now 400 cos
Cos 60. No, cos 30.
30
Sorry, 125.
times 0.25. Yeah.
Make sure they're calculators on
Yeah, make sure it's all the radians and all that, please.
Oh.
You're not allowed to set it back. You're not allowed to set it back.
Yeah.
Just shift 9 equal to.
86.602.
What you got?
86.602.
6.
Okay,
Yeah.
3 is 5.
Okay, torque is measured in newtons per meter. Is that fine with everyone? Everybody understand how what?
Why do we call something a calculator? You know when you clear and you recall the last answer.
Like when you just press
Answer.
on,
Yeah.
you press answer.
And then you press S to D.
So just say you say 7 plus 9 equals to 16.
Yeah.
Do another calculation, right? Clear it, right? I'll bring that 16 back now. Just recall. Huh?
Oh, it's this one.
Yeah.
No, answer.
Yeah.
Yeah,
Equals.
that will be this.
Okay, perfect.
That,
Yeah.
but if you clear your calculator, that whatever number was saved and that answers.
Yeah.
Okay? Right. So now we worked out your torque. Then they want you to work out the work done when the nut is turned through an angle of 70 degrees while the torque remains constant. So basically, it's forming what? An arc. And when it forms an arc, what do we use when we're working out? How would you work out work?
W torque.
W is equal to torque times
Angular.
angular displacement. We know the torque because we said it remains constant, so it's going to be that value. How do we get the angular displacement? Remember they told you it makes an angle of 70 degrees while the chalk remains constant. So the angle that it formed was 70 degrees. So we need to convert that 70 degrees into radians. You understand? It's in the question, they tell you the work done when the nut is turned through an angle of 70 degrees while the torque remains constant.
Okay.
Okay? So for B, we know that, okay, so this is your formula. Work is equal to torque times angular displacement. Right? Okay. We know the value of the torque because we worked it out. Okay? They're giving you that the angle is equal to 70 degrees. You need to convert the 70 degrees into what? Radians. How will you convert to radians? So we know that pi radians is equal to 180 degrees. Yes? From yesterday?
Yeah.
Okay. So I don't know whether I'm gonna say X amount, right? just X is just like a certain amount of it, right? So X amount of radians equal to 70 degrees. And what you do, you would cross multiply. So when you cross multiply, you're going to end up with 70 pi equal to 180 x. And then you'll end up with 70 pi over 180 equal to x amount. So when you put that in the calculator, what you get?
X amount of radians.
When I might we need to change the calculator so
So we don't change.
degrees.
No, this is just do the conversion. I'm not trying to confuse
So
yourself.
start with switch to 70 degrees straight to radians.
If you want to, but I don't remember. Because sometimes what you do, you convert it to radians, you forget that you convert it to radians, you will answer every other question after that, and then it's wrong.
So 1.22.
So x is equal to 1.222. Right? So now your angular displacement is equal to what?
Rads. 1.22 rads.
What's your angular displacement now? 1.22 radians. Okay? So, therefore, this one work will become
86.6.
86.603 times 1.222, which is
Yeah. 105.81.
105.81. Your units will be
Close.
81.
So how many decimals?
3.
Or 805 or 806. 806.
What you doing?
I will try. 829.
829.
829.
What you did before that?
That's fancy, yeah. But I think I used the full.
What's your setting
So,
there?
whichever is the right.
I used the full answer from the previous one.
Yeah, 806. Right? Because what he did was he just took, once he worked this part here out, he said answer times 86.603. Okay, so it's fine. Okay, y'all understand what we did there, guys?
Yeah.
Who's completely lost? Not bad. Not bad. Chema, you okay?
No.
What's up?
Yeah, just the second part.
So yeah,
Yeah,
what's good?
I'm lost. Why you did this 180, 70 thing?
Okay, so they told you that the work done when the nut is turned through an angle of 70 degrees.
Right.
Okay, so it's forming an arc while you're turning it.
Right.
Okay, so we need to convert the 70 degrees to radians.
Okay.
Okay, because remember we use angular displacement here.
Okay.
Okay, so you need to convert that angle into radians because you're converting it from an angle into angular displacement, right? So we know that pi amount of radians is equal to 180 degrees. X amount of radians will be equal to 70 degrees. We don't know what this is, we try to work for this. So you just cross multiply and then you solve for x. And then your x will come out in a certain amount of radians. which is 1.222.
Also, you're just converting that
70 degrees to
related. Okay.
Yeah.
Okay. No.
Calculation. But I convert my calculations to radians. How do you calculate 70?
You never did
So
that.
yeah,
It's
just to know.
alpha. So this is
We did radians in school.
No, in campus we did.
The confusion now is in mathematics, we switch the settings around. We working with degrees, change settings. Making with radians, change settings.
I must double check and see how you do it like calculation.
And now this side we don't have.
But see here, you're not changing anything on your calculator, right?
No.
You're just doing this conversion yourself. So you're not gonna mix up anything, or your calculator is not gonna be any type of anything, right? Okay, so the last one there, the power if motion takes place during 0.5 seconds. So should we here? There's our power formulas here, right? So you could either use this or we could use, but we're not given rotational frequency. So the only formula we can use is that, because they told you your time is equal to 0.5 seconds. We know the work done because we worked it out here. Okay? So power is equal to work done over time. This is equal to 105,806 all over 0.5. The answer comes to?
It should be more calculated. It should
211.
double it.
216.
216. 211, 216.
211, 216.
2.
So this will be in joules per second, which is also 211.216 what?
216.
Sorry.
No, there's something wrong there.
Sorry,
Give
sorry,
it
sorry,
216.
sorry.
It's fine, it's just small numbers, as long as the big number is right.
I think the stakes.
211, 612.
Okay,
Everyone laughs at me, right?
what it is? 2-1.
612.
It's funny when you do it, Pamela. That's right.
This is a classic, no? Let me be to you.
Yeah. 6 and 3.
Put one example again in the paper, right?
Yeah.
6 times 3.
Yeah, we can't because we get it wrong. So what we gonna do after? Okay. Your final again. Not bad. Not the worst thing we've done ever.
How many marks?
Yes.
How many marks? Not a lot.
You coming after so long and the first thing you're asking is
It come from love.
No, this year it's in with the combination of the other one, maybe like 10 marks.
10 marks.
Yeah. Not bad, it's easy 10 marks. That's in the exam.
The exam.
Okay. You got it?
10%.
You got it?
Yeah.
Yeah? Yeah, take it out. Hey, take a picture of it. So if I wait, it's how are you going to tell us this?
How you know when open that valve?
Yeah, you open it, you have the angle wrong, that's
No, I will use.
Yeah.
a big pole.
That's why you're penning the weak piece.
Yeah, take it out.
I know.
Yeah.
But that makes sense now.
Distance was too long.
Why you got
Too much force, too much power.
At least now you can go and do calculations and see which would make sense.
You will see integration well.
Right. Example 2.6. Okay, so they tell you that the torque applied to a nut by a spanner with a length of 0.18 meters is 16 newtons per meter. So, if this is your spanner, right, the center point of the spanner, the spanner's length is 0. Oh my god.
0.18.
Yeah. And the torque is
16 newtons.
16 newtons per meter. calculates the magnitude of the force applied perpendicularly to the spanner. So what they're telling you is that in this instance here, the force is applied perpendicularly.
Now
Eh?
it's okay.
Okay, so your length is 0.18
You
meters.
have to use a stupid
Your
sine
torque
cos.
is equal to 60 newtons per meter. What they want to know is the force. Okay, so our torque formula is equal to F times R. Perpendicular force, perpendicular distance, straightforward, right? So we just substitute 60 is equal to force times 0.18. Your force will be equal to 60 over 0.18. The force is equal to
3.33.
383.
What 3?
No,
Triple three.
triple three point triple three.
Triple three. Yeah.
Triple three point
Close
three
to close to that.
No,
three
somebody
three.
else said that wrong.
This would be newtons. Okay, straightforward, right?
Yeah.
It's fine. Next one, the magnitude of the force applied if the force makes an angle of 80 degrees with the spanner. Okay, so now there's your center point, that's the length of the spanner. Now it's acting at 80 degrees. That's 80 degrees. The length of the spanner is still 0.18. The force applied, the torque is 60 newtons per meter. Now they want to know the force applied. So, how would we work this out? Okay? Remember the force that we're going to be working out is going to be what force? Your perpendicular force. So if you had to show its components, and if this was your angle, F would be equal to, this part here would be equal to
Cos
cos of the angle. Okay? And what this here would be equal to?
10.
It would be equal to 10. Right. So, if we write out our formula, torque is equal to force times distance. Torque would be equal to, now because of this, perpendicularly, F cos the angle times R. Right? Now we know this value. We know this value. We know this value. We can solve for that value. Okay, so torque is 60. F cos of 10 times 0.18. So you'll say 60 divided by
1.8.
cos 10 0.18 equal to F. So therefore your F is now equal to
338.476.
338.476 newtons. Okay. What does it actually tell you about? Like if you're looking at it, right? Well, what does it tell you? If you're actually turning a nut or something.
So if you put it, if you're putting it at an angle, you have to apply more
More
force.
force than when you're perpendicular. That's like, you change a tire, why a tire spanner is always 90 degrees. If you look at the 4, when you're turning, you're always turning at 90 degrees. It's not made at an angle for you to apply force, because you're going to apply more force if you're turning at angles. Okay.
Makes sense about shit like that. That's it.
So, you got 70. Go there.
Yes.
If who's apply force and you can apply more force than more
Looting amanda amaningi ethi-angle value
Now
perpendicular.
you go to
Also change
To conversion amount. So,
you want 90 degrees
Which one was
because you don't have
Which one was
change
Newton?
calculated. Just use that bottom and shop. It'll be easier.
That's why whenever must don't have a piece of the Scott yes.
It's a big plaza present.
Very inenkinga height kodwa ubani wayekho uma ikhiya ifakwe kanje ngoba sonke sasiyithi noma ithi it's either it or it
you'll have to
ayazi nje ime ithi noma ithi
What I'm going to say distance.
not only percent.
That's it.
Yes,
I'm sure more calculate. I will see the number.
70,
So it was
right? That's your 70 values.
X6 would
thank you.
yeah
Okay, start again.
yeah
I don't like to talk.
So we just confirm.
That's it. Sure. Okay, take your outlet.
yeah
Okay, so run my example there.
come next week
Okay, sample 2.7.
folks you have to apply all this thing here and there's so many equations that you have
Oh, shit. Speaking of orientations, we have.
next week uzobhalisa equations usuwafundile azobeka wonke ama-equations ajikakudide wayo ukuthi kambe yini le kambe yini le hayibo khona ilawa maths angakufakela ama-equations but the problem is the application yawo ukhumbula ukuthi kambe leya yini kambe le kambe yini le
Please do it.
Ngida ukubhala ama-test awu-4 in one day
Yeah, it's maybe that you say it's 5 minutes, right?
And then a formula.
Yeah, so I went and printed the formula sheet. Okay, so yeah, this is the formula sheet that you would get. Whatever formulas that's not there means you have to remember it if you did it in a section, and then you have to familiarize yourself with whatever's there.
you can answer this, you know.
Yeah, it's yours. So,
In the exam.
oh,
You're gonna give us a new one in the exam.
no, in the exam it will come with it.
We can't bring our own.
You don't write all the time.
Okay,
Nice try. So far, right, in this formula sheet, we know the first column. We know all the ones in the first column. And then the second column all the way up to power is equal to
you see some additional formulas there.
Yeah.
So that was probably specific to a question. But remember, Bilal, I was telling you they combine sections. So you see like how they got angular velocity, power is equal to torque times angular velocity.
Yeah. You gave us that?
I don't give you power is equal to torque times angular velocity. Sometimes it's specific to certain questions. Because remember there's like a million variations of questions you can test. Okay? That's when you need to start applying your work.
Power same as well.
Is power the same as well? How can power be
No,
the same as
remember
work when we use
energy.
work to work at power? Power
Silly
is the same as work.
Now you're supposed to say there's no such thing as a silly question.
No, there's no such thing as silly question, guys.
Except we
This
become
is
idiots.
Okay, so yeah, so that's why certain questions, what the department loves doing that they like to take two sections and put it together. Like last year, something in maths, they took determinants and complex numbers and put it in one question. Then like here, they'll take maybe projectile motion formulas, you have to use it in like questions with torque and power and that sort of thing. Okay, so that's why I tell you all, please practice past year papers because you'll start to get used to the variations and the type of questions that happen. You don't wait for the day and then when you see the question, then you wonder, hey, where this came from.
Wait, so it's 280. What is this power here, right?
Yeah.
Another one. Below your 2 pi MC, right?
You know, right? It's kind of empty, yeah? See, the way they like talk to you is with a capital letter T.
Okay. But then now the other one, you haven't got the power divided is equal to work divided by time.
Yeah, that you have to remember.
So it's not all the formulas are here.
Yeah, that's why I printed this one. So that from now you can start getting used to. And also when you're as you go, right, you see certain sections we did was vertical projectile motion. Like you see that SC is equal to U plus V over 2 times T and stuff. Like try to I don't know, like highlight or make a note which sections was vertical projectile motion, which sections fall under angular motion. There's nothing there relative velocity and stuff, but yeah. So you can see there's still a lot more formulas we need to go through. Some of them you're familiar with, some of them you'll need to do. But yeah, I just printed a thing so you'll have something to work with, so you'll know. Yeah. Okay. Let's look at example 2.7. They tell you that a machine has a torque of 20 newtons per meter. 20 newtons per meter. At its spindle. So a spindle is basically a center point of a machine and it rotates, okay, which causes like a belt or something to move. Okay, so now your torque is not being applied at by a spanner or like physically applying torque to something. This here is mechanically it's moving itself. Okay, so your force is coming from that mechanical movement that's rotating the spindle. Understand that? Okay. The diameter of the spindle is 0.3 meters and it has a rotational frequency of 3 revolutions per second. So, the diameter of your spindle is equal to 0.3 meters and it has a rotational frequency of 3 revolutions per second. So, the spindle is, just say it looks something like this, right? At this point here, whatever this is basically rotating. Okay, so the force will obviously be generated from here and it will move towards the end. Okay, so the distance between the force applied and generated to the point of which it's actually acting on will be your what? Your radius. So your R value in this instance here, in terms of this formula here, is going to be your radius. Okay, because if you just picture like how a pulley would look, right? If this was the pulley, right, and this was rotating to obviously move the pulley. At the point at which it's in contact with the pulley will be the point at which the force is being exerted when it's pulling it and rotating it. Okay? So your R value will be your radius. Okay? Okay. So calculate the magnitude of the load on the rope around the spindle. Now the magnitude of the load is basically the force. Right? So for A, torque is equal to force times the distance, right? And remember, the point at which it makes contact over here is usually 90 degrees. It's perpendicular force, right? So your torque in this instance is 20. Your F we're trying to work out. So what would be your value of R?
Half of 0.3.
It's going to be half of 0.3, which is. So I'm just going to say here, R is equal to your radius is 0.15 meters. Everybody understands it?
Yeah.
Okay, so this is 0.15. Yeah, 20 over 0.15 is equal to force. The force is equal to? The textbook, they made a mistake there. I don't know why they got T is equal to
133 and 333.
It is 133
1,333.
1/3 newtons is equal to force. Okay, not bad.
But they got the same, oh, you mean the formula?
Yeah, see, they got T is equal to W times R. It's not work they're looking at, they're looking at force. Okay, now they want to know the work done by the machine during 30 seconds. Okay, so how would we do that? We would do that by working out the work done per revolution. Then we work out the work done for 1 second and you multiply by 30 to get the work done for 30 seconds. Okay, so your work done per revolution is this. Okay, so your work done is equal to 2 pi times torque. Okay, so this is work done per revolution. Right? So this will be 2 pi 2 pi 20, which is
125.664.
125.664. Okay, this will be in joules. Okay, now you're going to work out your work done per second. And how would you work it out per second?
For 1 second, it's 125.6. You look at use the ratio.
This is work done for every 1 revolution. For this machine, how many revolutions is it making in 1 second?
3. 3 times by 3.
How you know it's 3?
Because say
Because the rotational frequency of the machine is 3 revolutions for every 1 second. So for you to work out the work done for every second, it will be multiplied by 3. Okay, so you see work done per second is equal to 125.664 multiplied by 3, which is
376.992.
992 joules. Now that we know the work done per second, how many seconds they asked you to work it out for?
30 seconds.
30 seconds. So, your work done for 30 seconds would be equal to 376.992 times 30, which is equal to
1109.76
joules. Do you understand how we do this? It's not bad.
The trick was the work done per second.
Yeah, you all need to apply what they gave you.
So this is joules per second.
No, joules per second will give you power.
That's just the work for 3 revolutions.
This is just the work done for 1 second, the amount of work that was actually done. It's not a specific unit. You're looking at it as this was rotating. How much work did it produce in that for the time it
That's
rotated?
11 there.
But that was for 1 second.
11,000.
11,000.
100 like times 3 maybe.
Right? Okay. Guys, are you all understanding? You're all on the same page.
Yeah.
Is anybody confused? This is like the hardest thing they can ask you. No, I'm lying, they can ask that. But I mean, for the textbook, this is like the hardest thing they can ask you. Okay, it's not bad. It's easy, okay. So the output power. So power is 2 formulas, right? We know the work done for 30 seconds. Do you use 30 seconds, right? Yeah. We know the work done for 30 seconds. Also, we know the torque and we know the rotational frequency. So for power, you could have said work done over time. For your work done, it's 309.76 divided by 30. And, okay, tell me what number here. Or you could have said power is equal to 2 pi n torque. This will be 2 pi 3 times 20. What you get here, what you get here?
You still get to this answer here.
77.04.
That's your answer here.
Yeah. Let's say no.
Wait, that's the chorus.
So say
Let's say cancels out the 3. The time, yeah.
okay, so this year will come back to 376.992 watts. And then this year would be, can you put in a calculator?
Should give the same thing.
Same, right? 376.99 watts. So you could have used any formula. If you feel like maybe you did your work done part wrong, or like just say in the paper now you're completely stumped now, you're gonna do work done for 30 seconds, you could have still solved this question because you knew your rotational frequency given to you, and you still knew your torque because you worked out your torque. I mean, not worked out your torque was given to you as well. Right? So you could have still solved this question without working out the work done. Okay? Right. Okay. How are you doing at time, Nibila?
It's 20 past 1.
20 past 1. Okay, so you can do activity 2.3, do question 1 and 3. Not 1, 2, 3, 1 and 3.
Why don't brothers just
So 1 is 2 because then working out is 2 and 20. You get the proper answer. You get the good answer.
Activity.
Work done.
Must you do it now? For homework. What is
You
this?
can start it now.
120 if I
1
120
is 2.3.
the power is not work. But we got the same answers.
What's wrong, Jama?
I'm saying work done and the power, they are two different things, isn't it? But why are you getting the same answers?
In this instance, why we got the same answer?
Yeah.
Could be just a coincidence.
Which one? This one? No, this is work we worked out per second.
Yeah,
So work per second is
power,
power.
Oh, okay.
joule per second.
Oh yeah, okay, yeah, all that. Okay.
Yeah, actually, that is there. That thing's wrong then. The 376 is not
This one here.
It's not wrong, right? See,
No,
because
that's not wrong. The
It's not
units that we
joules.
use.
no, see, I mean, it's not that you understand. See, what happened was we broke it up in saying that for every 1 second.
Yeah.
So remember like how we did the meters per second, right? And if I asked you, so after if you did something in 10 meters per second, and I asked you after 1 second, how far did the car move? 10 meters.
Okay.
So in this instance here, after 1 second, how much work was that? Which is this. Yeah. Yeah.
So technically, power is joules per second, right?
One watt.
Easy thing to remember.
Joule per second. Yeah.
Okay, so we have the units there into joules per second.
Yeah.
The power is how much work is done in 1 second.
In 1 second, yeah. That's what the thing is saying, because it is technical.
No, it's not. Power is not work done per 1 second. It's work done
Well,
per time, right?
Yeah.
It just because that for 1 second, obviously, it would be equal to the work done. The power done would be equal to work
yeah, no.
because of 1 second. But after 30 seconds, you can see the time is different. Obviously the power output would be different to your
Yeah,
work,
yeah.
correct?
Yeah.
And then, you started this. You started this confusion, isn't it? There was no need for all that.
Sorry,
Yeah.
you sure formula is there? And V is equal to power. What's it?
Pi dm.
Yeah.
That capital N would be your rotational frequency.
I have what I have.
Try to get used to it because
Yeah,
sometimes
trying to
textbooks only cover certain formulas and then they run with that.
So
No,
relax.
you don't have
It
it.
doesn't
That's
have
part.
yes, right?
Okay, so like see even this one too, you don't have this. That's 12 times. So sometimes too, if it's specific to a question, like in that paper, one question came out and they only gave you these 2 things. So that's why they introduced this formula to show you that. But everything else we covered in majority. And usually this here is a combination of 2 other things.
This power is equal to force times velocity.
Yeah.
Yeah, so we give those to you.
Velocity. We're not going to do that. Just
What I
next
did this
section.
weekend, I could run and eat.
Yeah. No.
And
Yeah, so that brings us to the end of angular motion, module 2. Nice to finish module 2, Lisa. Okay, so on page 44, you'll see a summary of formulas. For question 3 of that activity 2.3, they talk about calculating effective torque. So you'll see on your summary of formulas, your effective torque is formula 16. They tell you effective in belt drives, effective tension is equal to T2 minus T1. But it's actually your higher torque minus your lower torque. It's not always T2 minus T1. Okay, so your higher value. It's the difference
So you
in
say
the values of the torque.
Positive.
Yeah, it will always come out your positive.
So even if
value.
you get a negative, you must convert it.
Yeah, because you'll take your higher torque minus your lower torque. Okay, yeah, that will give you a tension. Yeah, I think that's about it.
Then that's number 16.
We pretty much covered everything.
Effective torque is down to the tension.
Any questions on what we did?
Yes.
Yeah.
Yeah, it's attempting. So, you're working with past papers. You need to work with past papers.
Just that